from the in-class application 6. It says module 9, but it's really kind of module 8 material. Question 26 asks for variance, covariance, and correlation. So we have 3 different states of the world, 2 different stocks, and it asks for expected return, standard deviation, and then the covariance and correlation between the 2 stocks. Let me copy and paste this to a new page. Let me see if there's any other. Nope, there's no other information. All right, the first one is expected return. Notice that we did, and again, sum product is going to be the sum of the product of these 2 columns of numbers. So 0.3 times negative 0.05, 0.55 times 0.118, 0.15 times 0.274. And if we lock the probability column, then we can just copy and paste it all the way over. All right, so we got our expected return. Now let's do the deviation, well, the standard deviation calculation. So the first thing that we need to do is get the variance from the mean. Let me make sure that that's, no, that's not right. I'm going to lock the row here. All right, let's make sure that's, yep. Okay, so what we did here was we did each cell in the stock returns minus the expected return, and we locked the row, which allowed us to copy and paste this all the way down and get the correct formula, but also to copy and paste it across and get the correct formula. So let's do the squared deviation here. And then let's do the variance right here. So this is going to be the sum product of this and this, and we're going to lock the probability. And then the standard deviation is just this to the power of 0.5. I'm going to put this in percent terms because I think it looks prettier. All right, let's just check and make sure. Yes, we're good to go. Okay, so now we do the covariance. Okay, so let me just walk you through how we got this. The expected return is the weighted average of the probability and the stock returns. The deviation from the mean is literally just, for each state of the world, what's the difference from what we expect it to be. We square that because that's part of the definition of variance. We do another sum product or a weighted average of the standard deviations and the probability. And then we take the square root to get the standard deviation for each of those. The covariance is going to be very similar to the variance, except that here we are going to multiply the deviations. And notice that we're going to have only one column for covariance because we only have 2 stocks. So there's only K and J and K together. There's no like other one to compare to. Okay, the covariance is also going to be the sum product. And then the correlation is very similar. We're not going to take a square root, but we're going to take the covariance and divide it by the standard deviations multiplied together. And so what we have here, let me get rid of some of those decimal places. What we have here is that the standard deviation of stock J is 10.67%, but stock K is 2.44%. And you can kind of see that these returns are much more spread out, and these are less spread out. That's why the standard deviation here is larger, and this one's smaller. And the covariance here shows us, well, the correlation shows us that 98% of the movements are in the same direction. So as the bear market hits, both stock J and K do poorly. When the bust hits, oh, I think I wrote these in wrong. When things go I guess, good or poorly, however you want to look at it, these stocks do much, much better. And so 27% return and 9.8% return, basically they go in the same direction. So a correlation of 0.98 means that the stocks go in the same direction almost 1-for-1. So let's just check our answers and make sure. We've got 10.67 and 2.44. We already saw that. Oh, I should have put bull here. That's what it is. And then the correlation is 0.9836. We could not have gotten that if the covariance had been incorrect, and so we got both of those. And the answer here is that these stocks are, despite the fact that the standard deviation on this one is much, much higher, they move in the same direction, and so they're very highly correlated. And there's not much benefit that you could get from diversification if you made a portfolio of these two stocks.